We're here today to talk about FreeSWITCH as a microservice. That's the title of this talk. And I'm actually going to kind of go a little bit over what that really means, maybe even what microservices are. Who here is not familiar with a microservice architecture? Raise your hand if you don't really know what I'm talking about. Okay, so some of you will just be like, wait, we get this, it sort of makes sense, we'll go through it quickly. Hopefully we'll show you the reason why I think this is an important thing to talk about with regard to FreeSWITCH and sort of the surrounding services. Anyway, my name's Evan McGee. I'm the CTO at RingPlus. We are an MVNO running here in the US. We just passed around 100,000 subscribers, and what we do is we're trying to bring sort of web development and that sort of mentality to the realm of telcos with things along the lines of in-call translation and lots of other sort of very fun applications that bring a lot of value to people in the telecom space. When we do consumers, we market it to consumers. But anyway, enough about what I do for work, and on to why we're really here. So what is a microservices architecture, right? It's not this. It's not the big monolith, right? What it really is sort of a decomposition of sort of a monolithic architecture into a bunch of small little services. And what I mean by that is, when you first get started building any kind of application, generally you build it you choose a framework, you choose a language, and you just get moving, and it's fast, and it's fun, and you're having a great time, and you're moving quick. And then suddenly something happens, and you need to scale that somehow. Let's say, just one of the pieces takes off. In this case, let's choose billing. Suddenly you're getting a lot of billable events. You're doing a lot of, which is great. You're making some money, you're having a good time, but you really need to be able to scale that one particular side of the application. So maybe you deploy a bunch more instances of your monolithic app across a bunch of VMs, you spin up some DigitalOcean containers, and off you go. And then something else starts to happen. You have a lot of background jobs. You're sending a lot of emails now because of all of your billing. So we'll need that to scale a little bit. And those need to be scheduled in the future, so then you have a bunch of background workers running, and suddenly you have a situation where you are actually needing to scale things independently. You might need a ton of background workers, maybe over a promotional period, but you don't really need that many running day to day. And suddenly you have just a lot of instances of one giant application that you're only using small pieces of at any given time. And that's the point where you might start thinking about, hey, how do I break these out into separate services that I can scale and run independently? And that's where you start getting into sort of the microservices architecture sort of paradigm of things. And you can see the old school monolithic one is a lot simpler. It's a much simpler architecture. You have all your built-in framework hooks you can use, but you are generally confined probably to a single language or framework for most of it. If it's Rails or Django or whatever you want to use, you're sort of locked in there a little bit. It is a little bit inefficient to scale, like I was just talking about. And one of the big problems is that onboarding new developers can be substantially difficult because there is usually a lot of code in there, some of which might not have been touched in a long time, and maybe is not very understandable to a brand new person on your team. So it requires a big depth of knowledge in order to really start contributing potentially to that code base, which is something that no developer wants. You want people to jump in, help out right away. No one wants to show up at a job and be like, I need to take 2 months to figure this out. You want to be able to get in there and actually work with people. And so microservices can kind of help that, right? It is more complex, and we're going to get into that, and that's probably the biggest drawback and something that you need to really seriously consider. But it does allow for that the decouplement of services, and you can very rapidly start to work on and deploy different pieces of your architecture without having to really dig into a giant application. It does increase, again, with the complexity comes a potential increase in fault tolerance and things like that. We'll kind of talk about that later. Again, the trade-off here between sort of a monolithic app and a microservices style of architecture or a service-oriented one really is a trade-off in sort of ops and how much you're willing to manage the complexity of that. Which brings us back to FreeSWITCH, right? So FreeSWITCH itself does not live inside of a bubble. Right? It's great. The first time we all stood up our first FreeSWITCH or Asterisk, we got calls flowing through it, this is amazing. I'm touching the real world. And when we do it with cell phones, it's really a wonderful feeling. But it doesn't live inside its own little bubble. You have lots of things that go along with it, right? There's things like billing, you have fraud management, call tracking, all these things kind of start to pile up real quickly. You have to just deal with all of this stuff sooner rather than later. Unless you're just routing phone calls for free or just doing it for fun, which if you are, I would like to know because I would like to make some free calls. And these different business rules usually require some very different kind of domains and processing, right? If you're doing fraud management, it's very different than if you're trying to do any kind of billing, or if you're trying to do any kind of performance monitoring. You're going to use different tool sets, different languages, right? Maybe your billing is written in Ruby, maybe all of your fraud management is in Kafka, using Go to sort of consume that and throw things out. You're going to use and choose the right language for what you want to do. At least you should be. You shouldn't be locked into one particular framework because they just don't work as well for any given paradigm. But let's use an example here of how you can get FreeSWITCH into this mindset. So let's say you set up your FreeSWITCH box and you're like, great, I have all my stuff running, but I need to start thinking about my setup in terms of services and how am I going to get these things. So first thing I want to do is get rid of any static configuration, because I'm going to be deploying FreeSWITCH in random spots, maybe in a data center that we own, maybe in a public cloud, and I need to be able to pull configuration from a central repository of some kind. So mod.mxlcurl is a great example of a built-in module that helps do this, right? Somebody comes in to register their zip client, it can query a remote API for that registration information. That then sort of registration little microservice down here can actually do some business logic in the background. Maybe it can determine if the person hasn't paid their bill, so it actually doesn't allow the registration to happen. Maybe that then triggers and again an email to fire off to them saying, hey, we saw you tried to register, it didn't really work, or maybe a push notification if you've already built like a mobile app, right? And it's actually very simple. Turning on mod XMLRPC is a very, very, very easy thing to do inside of FreeSWITCH. They've made it like almost drop dead easy. And this is kind of really all you would need if you're using, this is an example from Rails really, is you just drop this sort of code here into your configuration, and then you get rid of, this is kind of really all the Ruby code you need. There's some more magic behind that, but if you're looking, say basically if that endpoint is not created, you just sort of render it in your controller. That presents a view. The view is just the actual XML sort of document that you want to display, and that pumps it right back out to FreeSWITCH, consumes it, and off you go. So this is just going to be stuck into like any kind of Rails app. There's more code behind that. If you want to know more, come find me later. But it really is sort of that simple. You can get that up and running like, in an hour if you wanted to. So again, decouples that sim point stuff. Works for dial plan. It can, again, this works, particularly XMLRPC works for dial plan configuration and also for phrases. It can pull a lot of great information from a central database. So I would recommend thinking about this kind of thing. And it also aids in integration to, let's say, eventually, this is registering to FreeSWITCH. Eventually, you might want to switch to that when your load gets high enough to like a mid-registrar like Camelio. And if you're doing that, you're going to want to get that information into some sort of central repository anyway. So this is a great stepping stone to be like, hey, eventually we're going to have to make this a lot bigger and more scalable. So let's just get this information up and out of there, move forward. All right, but something more fun. Okay, so that's great. Everyone loves registration information, right? It's like the highlight of everybody's day. Let's do some more serious fun ahead. And I think serious fun, when I say serious fun, I mean using exec set. Now, I don't know how many people use this heavily. Raise your hand if you use a lot of exec set. Anyone use that or even know what it is? It's actually a lot more powerful than you might expect, and it's actually kind of fun. So let's say you're really big into 12-factor, right? And you're using lots of environmental variables, and you'll be doing this a lot if you get into Docker and these kind of things, which I'll get to in a minute. You might want to do things like set your internal SIP port. And if you want to do that, well, guess what? You can throw a preprocess argument in here, use exec set to basically echo the internal SIP port environment variable, and it sets that in your vars XML. Not so bad. Let's say you don't know the IP of the container you're on or something else sort of fun like that. You're deploying in a weird configuration. You want to figure it out. Well, again, use this little guy right here, right? Use exec set, and then you can do this little sort of bash scripting here that allows you to pull out the IP address of your local v4 interface and at F0, right? You can just whichever one you want. Maybe you have that on a VLAN or something, and allows you to kind of set all these in advance. So you're like, great, Evan, that's awesome, but I have real problems. I don't have these silly little bash scripting problems. Well, great, then no problem. Then perhaps you want to throw down an exec set that actually calls like a little Go routine right here or something else. And that Go routine can actually pull some sort of information from any service you want. Maybe you have a Redis that has some sort of like key value store. You need to get something out of that to inform the container to put into here. In this case, it's trying to set RTP start ports. And what that does is actually talk to a service which then updates firewalls and updates forwarding configurations based on when the container is actually launched. So it dynamically can allocate RTP ports based on whatever data center it's being launched in and everything else. And it's just, it's just a little exec set command here. So, what this allows you really to do is run commands that inform FreeSWITCH while it's loading. And one interesting thing too is the pre-processed variables set in here are not overwritten by things like modem XML curl. That's correct, right? Looking at Brian, yeah, I think that's right. So you loading these up first, you don't overwrite these later with your configuration, which is also something that is tough because you thought, oh, I can just use mod XML curl to update this kind of stuff. Later you can't. Like this is defined up front and it's just that way forever. So again, a very powerful feature that I don't think a lot of people use or know about. So look into it if you think you could use it for your environment. I just talked about that. Okay. Well, that's great, that's all, but that's mostly all pull. You're mostly pulling stuff into FreeSWITCH at that point. What if you want to push things to FreeSWITCH? Well, there's lots of options. Anthony talked about a bunch of them, so I won't really go through these that heavily. There's Ruby, JavaScript. There's every kind of thing you could want to do to actually push information down. You can even write your own with XMLRPC. So whatever language you're comfortable in, you can sort of wrap a web server around it, and just off you go. So I would just take a look at any of these on your own time, and you can figure out how to push information down to FreeSWITCH to do whatever you'd like to a channel. So setting this up does sound kind of complex, doesn't it? Right? This sounds like you're like, great, okay, now we have FreeSWITCH. Maybe we're talking to services externally. This is kind of fun. We're pulling the information we need. We've sort of made our FreeSWITCH more isolated in the sense that it can be deployed in many different places and many different versions of it without having to really pull down a lot of configuration files from a central repo. Well, let's talk about one way to actually do this deployment, and that is Docker. And so I talked about Docker last year when I was here, and I'm still talking about it. And the reason why is because it's still evolving pretty quickly, and by pretty quickly I mean insanely fast. Some of the best stuff they just released, I seriously, about 3.5, 4 weeks ago. So it's a great project, and it's moving at lightning speed, but it also is missing a couple of pieces, and they're still figuring some stuff out. So, caveat emptor. So again, containers, people who don't really know about Docker, this is just kind of a little brief overview, right? It is basically a container orchestration framework that allows you to basically replace your virtual machines with sort of small isolated Linux containers. Generally in the Docker version of things, they should run one process and one process only. You can do that if you want, doesn't really matter. Do it the best way you want to. They're supposed to be sort of little ephemeral units. They're supposed to be, you can think about it as VMs are like cattle and containers are like kittens. Wait, no, reverse that. VMs are like kittens. You name them, they're very special, you love them, you hug them. And containers are like cattle. They have numbers. They're taken away and slaughtered when you don't need them anymore. You can scale up and down your herd depending on how much beef is worth at any given point. That metaphor is getting a little deep, so let's move on. But anyway, they can also do a lot more packing in terms of actual information density because the containers do have a lot more shared resources than virtual machines, right? Virtual machines have their own kernels, their own memory space, everything else, and containers share all of that on one host. So you actually get a lot more density in there, which is great for things like FreeSWITCH and other, I feel like, real-time communications that really need that as close to the box performance as possible, and also generally can consume an entire machine. They aren't, they aren't locked like a single CPU. That's going to come up again in a minute. So Docker networking was always a problem in the past, right? This was the big thing I talked about last year, is that it just did not work well unless you used the host-based networking options. Like you basically just didn't run FreeSWITCH on anything besides the just native networking stack. Well, guess what? It's gotten better, right? They've made it better over the year. The dragon of terrible networking has passed. This one they just released back in June, 1.12, actually allows for very, very easy multi-host VXLAN routing. They're actually doing things now. They sort of do a VX overlay network. Allows you to do multiple hosts. Now you're not stuck on a single host. Previously, it was you had to use one computer, and outside that computer was kind of a mess. Now you can go across nodes, across data centers. It's much, much more elegant. They've deployed built-in sort of state reconciliation to the actual Docker engine itself. So if a container just sort of randomly dies in a data center somewhere, it knows that, heartbeats it, and can spin up a new one depending on the rules you have. And this is also just built into the basic Docker engine now, which is great because this was all sort of third-party stuff that kind of vaguely worked and no one really knew. They do like even more simple fun things, like they are using the built-in Linux IPVS, which is something I didn't even know was really in there. I had heard of it in the past. It's a built-in switching, level 4 switching framework in the kernel that's been there for like 15 years. And now they're using that to do things like inbound load balancing. So you just tell Docker which port you want to run on, let's say port 80 for like a web server, and inbound connections will then automatically load balance across all the containers defined on that port. So if you have 5, let's say Pumas running at once, and suddenly you get a spike in traffic and you deploy that to 20, you just scale up to 20 and it will automatically load balance across all of those without having to set up like an HA proxy and update that. And then that has been a long-standing problem, which is how do you do this dynamic upscaling and then load balancing across. So they just built it in, and so now you don't have to worry about it, which is kind of phenomenal in my mind. Again, note, it's still a moving target. The documentation on a lot of this stuff is lacking at best. Best practices are also being developed. If you do it, yours might be the best practice. So get out there and write about it if you do it, because people need to know. And then, again, service integration and discovery is a big part where once you get these things up there and moving, how are you going to figure out which services are in which location and how it's all working together? There are third-party plugins like Console. Console is a good example. Look that up if you're looking for sort of a discovery mechanism. This is still being debated in the Docker community of how to do service discovery the best. There's different, different attitudes. So let's go into like a practical use case here real quick. This is a graph of CPU usage over the course of a week. And you can see that, things during the week here get pretty tight. This one container was getting down to about, what was that, 25% or 20% free CPU. And then here on the weekends, things kind of lighten up a little bit. People don't call as much on the weekends, apparently. So we at RingPlus use Adhesion, the Ruby app, to do all of our logic. We use Adhesion extensively and exclusively because it really does allow for just very, very quick development and deployment of sort of advanced services. We can actually just create very exciting, fun interactions with the cell phone calls sort of in real time. And we really love Adhesion, and I can talk about that for hours, but there's other talks about it. Problem about Adhesion is that we use Ruby with MRI, which is the C-based version, and it is locked. It's got a global interpreter lock, so we can only use a single CPU at one time. It's a problem, right? So if you have a lot of call traffic, you can peg that CPU, and then the whole thing slows down because the processing of the actual business logic as it goes to the sort of the Ruby dial plan can slow down. The answer to that can be JRuby if you want to use that, but JRuby comes with its own issues and its own, kerfuffles. So take that with a grain of salt. We stick with MRI just because it's simpler, and we decided to basically scale the Adhesion instances themselves versus trying to use a different kind of, the Java bytecode to do it over multiple CPUs. So then we come to the problem of what if the call volume on a particular node is exceeding that sort of CPU capacity, right? You have some sort of wonderful adoption of a new feature. I call it the Pokemon Go syndrome, right? Where it's just like everything's falling apart. And if anyone played that game, it was just the worst for like the first week. Well, just scale the nodes, right? And you say that. Everyone says, you talk to somebody, the CEO says, scale the nodes. And you're like, well, okay. And so everyone just stares at each other for a while and then has some coffee and leaves. The funny thing about this is that FreeSWITCH, actually in this case, this is kind of a side thing, is that FreeSWITCH is kind of very rarely the blocker on this. As Anthony said, FreeSWITCH can pump just a lot of calls. It really can push through, thousands and thousands at a time. It's very rarely the problem. Maybe you don't want your FreeSWITCH to have thousands of calls on it at once. That's a different set of arguments. Maybe you only want it to have a couple hundred. So if something does happen to, say, the VM it's on or in your data center, if you lose that, it only maybe like terminates 100 calls. Or you can have sort of high failover thing on that. It depends on your business case. But Adhesion has a nice little functionality here. And this is thanks to the mod Ryo and Chris Rienzo. You can thank him for this. You can have many, many Adhesion clients in one server. So many, many, many Adhesions can actually talk to one FreeSWITCH instance and have all of the communications sort of load balanced across them. And that's great. So we come back to this again. Oh, and by the way, one of the things here is if you want to scale down on the weekends, you can save yourself some money. Turn off those machines, right? If you're running half the machines for 8 days a month, you're saving, what's it, like 26.6% of your, whatever. So you can actually save a lot of cash on the weekends, and everyone likes that. So anyway, If you wanted to scale this up, literally once you have would be like on a single node, but once you have your sort of Docker cluster running, you can literally just say Docker service scale adhesion 20, scales it to 20 nodes. You can look at it, and you can see that suddenly there's 20 running, and here's the latest, and there's one FreeSWITCH running, and they all just sort of work together. And it all just kind of, you can do that across multiple data centers. You can have all kinds of fun stuff. Along with this, of course, comes a lot of like Ansible scripting if you need to update other things, right? That's the sort of unspoken thing here, is that scaling the actual nodes themselves is pretty easy, but there might be more side things you need to deal with on a more DevOps-y level. But they actually are pretty simple to go through, and I would recommend using Ansible if you're going to use anything. So, this just kind of goes through what I was talking about even more. If your host monitoring sort of detects, a low CPU condition node 1, maybe you're using collectd to actually do that, and you're monitoring it on a different service. And again, how this is tying back into FreeSWITCH as a sort of microservice is that FreeSWITCH is just one part of this whole overall framework, right? We're treating FreeSWITCH as sort of one small little piece, and FreeSWITCH itself, as we saw earlier, treats its little sub-pieces as individual services. So you use mod XML curl, you use everything else to pull your services into FreeSWITCH, but then everything else uses FreeSWITCH as its own little service as well. You can do active call monitoring. You notice that something is going wrong, you don't have enough CPU time, whatever else is happening. You use Ansible to spin up a new DigitalOcean container because you just need to rapidly turn this on. Starts it up, you get the sort of the overlay network running real quick. You can then quiesce the adhesions that are actually on that box with FreeSWITCH so that it has more room to grow. Maybe FreeSWITCH needs more CPU power on there. So you actually can tell adhesion. Adhesion has a built-in HTTP server. You can tell it, say, hey, stop accepting any more calls. We want you to terminate. It can gracefully then let the calls that are existing on that box finish, giving FreeSWITCH more room on that one particular instance. Or you could turn on more FreeSWITCHes. It depends, again, how you want to construct yours. And then you can update. If you end up setting up a new FreeSWITCH, you just send off maybe another Ansible command to your Camelio that updates the dispatcher to tell it, hey, you have more clients online, whatever you want to do. So there's a lot of different options here. Again, it's sort of, once you get into this sort of idea that all these things sort of live by themselves and are all accessible APIs and should be talking to each other all the time, that's where it becomes sort of a very fun, very sort of dynamic environment, right? You have just a ton of, oh, whoops. These are all going to just fade in by themselves. Just a ton of opportunity to actually use this in a very interesting way. If you basically make everything, and you can think about it like the AWS model as well, if everything is an API, then everything can talk to everything else. So if you need your billing API to talk to your user API, if you need your fraud to then, maybe the fraud API needs to update the RB, in our case, RBT selection, RingPlus uses ringback tones. When you make an outbound call, we play music or advertising, help subsidize the phone calls to make the service free. That selection of what the RBT is depends on a lot of factors. Some are fraud factors, some are where you've been recently, if you're on the social side of our social network part of our platform. So those all need to talk to each other and say, hey, this guy was just visiting this one particular page on the social networking side. Maybe we should actually put the next into his ad rotation of the product he was looking at, because he seemed to spend a couple of minutes on that particular thing. And they can just all talk to each other. And that is sort of the essence of what this microservices can be, is that it decouples all this information so anything that needs to talk to anything can talk to anything. Let's just go back through all of these guys. That was a bad fade-in copy. There we go. And in the case of deploying the Docker, it's not a magic pill yet. It still requires a lot of devs, ops, and DevOps and management, and there's a lot that goes behind it. And it's complex, right? So just to wrap it up, basically, I would say, to be honest, if you can help it, just don't start with a microservices right away. Don't do that. It is a complex set of problems you're going to get into real fast, and you might get bogged down in the actual deployment and architecture of it, and not actually building the thing that makes you do your job or actually be successful, right? You can focus on getting that MVP out there and actually making your product work, but always keep an eye towards breaking that apart. You're going to have to, at some point, scale this thing faster or weirder than you ever thought. So when you're building things, try to think about the patterns you're using. Maybe follow a services or an operations style pattern. Use internal APIs in your code that oh, okay, eventually this thing's going to be sucked out over here, and we can use this as a totally standalone service when we get there. And you will get there, and when that pain hits, you'll thank yourself. You do think about FreeSWITCH and these things as also very small services. I know you can, again, run thousands and thousands of calls over one of them, but do you want to always do that? Maybe you can run 100 calls over 100 of them, right? Is that efficient? Not particularly. Would it satisfy a lot of use cases? Probably. People have a lot of reasons for doing that. We run quite a few of them at RingPlus for different reasons, and if anything ever happens to one of these containers, people are used to their cell phone calls dropping. They just redial, and there's almost no problem there at all. Whereas dropping, several thousand calls at once, there have been problems like Hurricane Sandy. We were running a lot of things in New York. That was a problem for a day or two. So having the ability to keep these things all running in different places and have sort of consumers not really notice is a big benefit. But anyway, that's sort of just what I wanted to give you guys kind of a brief overview of how this all fits together, how it all works. Again, my name is Evan McGee. You can find me at Startled Marmot. There's my email. Feel free to reach out. Thanks so much.
Yay.